के बाद फिर कुछ और एक्सपेरिमेंट्स में जिससे पता चला कि जैसे एक्सरे बम्बार्ड करवाए थे रदरफोर्ड्स ने, तो उससे पता चला कि नहीं, ये सिंपल एटम जो होता है बस सिर्फ सिंपल एटम ही नहीं होता है, बल्कि इसके अलावा इसमें कुछ और भी कंपोनेंट्स होते हैं। आप में से किसी ने माइक्रोफोन ऑन रखा है, मुझे मेरा आवाज इको हो रहा है, प्लीज आप ऑफ कर लीजिए ताकि आप मेरा बात सुन पाए। और जो क्वेश्चंस होगा आप चैट पे कोई भी लेटर टाइप करके मेरे को देंगे, मैं उसके बाद आपको बोलूंगी माइक्रोफोन ऑन करके आप क्वेश्चंस के बाद आप पूछ सकते हो, ठीक है। तो जो पहला था कि एटम जो है स्मॉलेस्ट पार्टिकल है, लेकिन बाद में पता चला कि नहीं, ये दो पार्टिकल्स का कंसिस्टेंट होता है, एक न्यूक्लियस पार्ट विच इज पॉजिटिवली चार्ज एंड इलेक्ट्रॉन विच रिवॉल्व अराउंड द न्यूक्लियस। पहले था कि सिर्फ एक पार्टिकल्स होता है न्यूक्लियस में, दैट इज प्रोटॉन्स विच इज पॉजिटिवली चार्ज, बट लेटर ऑन चैडविक डिस्कवर्ड न्यूट्रॉन्स। उनके हिसाब से न्यूक्लियस जो होते हैं उसमें प्रोटॉन्स प्लस न्यूट्रॉन्स होते हैं, ठीक है। तो प्रोटॉन्स और न्यूट्रॉन्स का एनालिसिस जो था वो डिफिकल्ट इसलिए हुआ था क्योंकि हम लोग उसको प्लीज अपना माइक्रोफोन जिन्होंने भी ऑन करके रखा है प्लीज उसे ऑफ कर लीजिए क्योंकि इको हो रहा है थोड़ा। तो जो मास होते हैं इन दोनों का ऑलमोस्ट सिमिलर होते हैं। मास ऑफ न्यूट्रॉन्स होते हैं 1.675 इंटू 10⁻⁻24 ग्राम, जबकि प्रोटॉन्स का मास होता है 0.005 से बेसिकली डिफर करता है, तो ऑलमोस्ट ये इक्वल होता है। तो जब हम लोग मास नंबर लेते हैं तो मास नंबर क्या हुआ, न्यूक्लियस का सम, यानी कि नंबर ऑफ प्रोटॉन्स प्लस नंबर ऑफ न्यूट्रॉन्स। हम लोग इलेक्ट्रॉन का मास नेग्लेक्ट कर देते हैं क्योंकि बहुत ही स्मॉल इसका मास होता है, ठीक है। तो हम लोग मास नंबर बोल रहे हैं यहाँ पे, इसलिए नंबर ऑफ प्रोटॉन्स प्लस नंबर ऑफ न्यूट्रॉन्स। अगर मास बोलेंगे तो नंबर ऑफ प्रोटॉन्स प्लस नंबर ऑफ न्यूट्रॉन्स इंटू 1.675 इंटू 10⁻⁻24 ग्राम से हम लोग मल्टीप्लाई करेंगे, तब हमें अपना मास मिलेगा, ठीक है। एटॉमिक नंबर क्या होता है, प्रोटॉन के इक्वल होता है, प्रोटॉन इज इक्वल टू द नंबर ऑफ इलेक्ट्रॉन। तो हम लोग क्या करते हैं, मास नंबर को भी हम लोग एटॉमिक नंबर से, सॉरी, नंबर ऑफ प्रोटॉन्स को भी हम लोग एटॉमिक नंबर से रिप्लेस कर सकते हैं, ओके। तो एटॉमिक नंबर क्या हुआ, इट कैन बी इक्वल टू नंबर ऑफ प्रोटॉन और कैन बी इक्वल टू नंबर ऑफ इलेक्ट्रॉन्स। आइसोटोप्स जो होते हैं, हम लोग अभी तक जान रहे थे कि हाँ, ये कुछ बेसिक्स टर्म्स है जो मैं आप लोगों को बता रही हूँ, जो बाद में जब हम बायोफिजिक्स पढ़ेंगे तो उसमें ये सब टर्म्स यूज होंगे, तो मुझे वो उस टाइम पे वो रिपीट नहीं करना पड़ेगा। ये बेसिक्स टर्म्स है जो आप लोगों ने +2 लेवल में पढ़ा हुआ है। तो आइसोटोप्स क्या होते हैं, सेम।
Excuse me, ma'am.
हाँ, यस यस।
Actually, I have a question.
हाँ, यस।
Because we are writing our paper in English and I don't know Hindi of
ओके
that much.
ओके
Can you explain everything in English only?
ओके ओके, आई डोंट हैव एनी प्रॉब्लम, ओके
Okay, because I'm not so much familiar with Hindi.
okay okay, no problem. So we have come across to यहाँ तक तो, yeah, till now you have understood ना? Hello, hello, who
Yes,
was,
yes, yes, I have
okay
understood.
okay. So isotopes is what, the atoms having the same atomic number but different mass number. So and the condition is that the element should be of same species. So here hydrogen is there, it is of same species, isotopes, okay. If we talk about the isobars, isobar is of different species having the different atomic number but the same mass number. Likewise, isotone is different in mass number as well as atomic number but will have the same neutrons. And how we express the neutrons, neutrons is mass minus number of atomic number, okay. The 14 minus 6 is 8, 15 minus 7 is 8, so here it's the neutrons, okay. So now there is a confusing term like element and atoms. So what is difference between atoms and elements? Elements are actually the group of similar atoms. So in living world, if we will consider only for the living world, then there are basically 6 types of atoms, which is carbon, hydrogen, oxygen, nitrogen, phosphorus and sulfurs. So to remember all these sequence, what we do, we can code it like CHOMS. You use chowmin, na? You used to eat chowmin, so better pronounce it as CHOMS, okay. It will help you to remember these six element which is measured in biology or in biological world. There are also some other elements are also like iron is there, magnesium is there, but if these are the minor elements. So basically we focus on these six elements. Okay. And when these elements will be grouped together with the help of bondings, then it is known as molecules. And basically there are two types of bondings. One is the intermolecular bonding and another is the intramolecular bonding. In intermolecular bonding, there are three types of bonding. One is the nonpolar covalent, polar covalent, and ionic bonds. And in intramolecular bonding, there are hydrogen bonding and van der Waals forces. Okay. Uh, if we talk about the non-polar covalent bond, then if two elements are sharing equal amount of electrons around itself, like carbon is there and it will share the equal number of electrons. So there will be no polarity there. Okay, because equal sharing of electron is there. But if we will talk about the polar covalent, we generally take example of water because it is easy to understand. Because of higher electronegativity of electrons will be attracted toward the oxygen from the hydrogen because it is electropositive and it is electronegative. Okay, so what will be the resultant directions of the electron attraction? It will be towards the upside. So it is creating a polarity of the negative, and here it is the positive charge. So it is creating a polar nature. And what about the ionic bonding? In the covalent bond, there was equal sharing of electrons between the elements. But in the ionic bonding, what will have? There will be partial sharing of the electrons. So because of which, it will create a partial charge of positive in NS and partial negative charge in chlorine. I will discuss all these two also in my coming slides, but basically we will focus on the water. From there you can understand the what the actually hydrogen bonding is and what is the van der Waals forces is. Okay, so move toward the water. We discuss about the structure of water. It is tetrahedral because it's having the lone pair, and if you will look like a lone pair will be expressed here, it will form a tetrahedral structure. Okay, so suppose there are so many molecules of water and how it will interact with each other. So when there is no certain bonding, that it will align in disorder manner. But as there is certain forces is there, so it will align itself because with the help of the hydrogen bonding. Now my question is here that if oxygen is negatively charged and hydrogen is positively charged, it is forming a hydrogen bond. But there also in water, if we are taking a beaker and it is filled with water, then there are so many oxygen molecules and so many water molecules. Then why they are not repelling each other? Why? How this hydrogen bonding is forming? Because there will act a force, repulsive force between the similar types of atoms, and it will repel each other. But even then there is a force existing there, which is hydrogen bonding. Then how they come to interact? Can anyone have any idea about this, how they interact? Can anyone say? Yes.
And
Hello.
what is your question actually?
Question is that there are oxygen molecule also in, because water, how we express water, like we have extra structure of water like this. Okay, so if
Uh-huh.
it is bonding hydrogen bonding with the hydrogen, oxygen bonding and hydrogen is bonding is forming a hydrogen bonding. But there can also be chances that hydrogen molecules are there and water and oxygen is there, then they should repel each other and they should not interact with each other because of having the similar charges. And here also condition is there that positive charge is there, so they should repel each other. Even then they are forming hydrogen bonding. Then what is the force is there which is overcoming this repulsive force? Anyone?
Oh.
Anyone? Am I audible to all?
Yes, ma'am.
Okay. So there is a force known as electrostatic force. You might have studied in physics that electrostatic force is inversely proportional to 1 by d square. D is the distance. And what is the formula of the electrostatic force? There is a constant and Q1 Q2 by d square. Q1 can be the charge of one atom and Q2 can be charge of another atom. And here the main factor is the distance. So when oxygen and hydrogen is there, and hydrogen is a very small particles. Okay. So anyone have question? Some message is there. Yes, electrostatic force is there. So Soros has answered it as electrostatic force. Okay, so what will happen? Hydrogen atom is very small, and oxygen is large atom, and so because of this, the distance between the nucleus of the hydrogen and nucleus of the साजिर आपको आवाज नहीं आ रही है. आप अपना माइक्रोफोन ऑफ कीजिए और स्पीकर ऑफ कीजिए, माइक्रोफोन ऑन कीजिए. You will get my voice. 1 minute. Sajira is not getting my voice. Okay. Okay. So, because of this lesser distance between hydrogen and oxygen, what will happen? Because of the less distance, force will be high, and this force will overcome the repulsive force. So, for the formation of hydrogen bonding, there is electrostatic force. Okay. So we know that water is a polar molecules because it is. I have just discussed that how oxygen is attracted more toward the oxygen, so it is a polar molecule, and polar dissolves always polar. Why? How it happens? Suppose we have added NaCl to the water solution to water. So what will happen? NaCl has a charged molecule, so it will break down into its constituents as sodium ion and chlorine ion. And as sodium ion has positively charged, then it will attract the negatively charged oxygen, whereas chlorine being a negative charge, it will attract the positively charged hydrogen, and it will form a bonding. Because of these reasons, it gets dissolved in it. But what will happen when we will add a nonpolar compound? So when we add a nonpolar compound, because it's nonpolar, it will create a certain disbalance in in water molecules. And now what will happen? So uh, uh, what what happened, Juhi? Hello, 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 hello. हेलो. जिनका भी वीडियो ऑन है, जिन्होंने भी अपना कैमरा ऑन कर रखा है, प्लीज ऑफ कर दीजिए उसे, बिकॉज इट इज डिस्टर्बिंग अदर स्टूडेंट्स ऑल्सो. Okay, so when we will add a nonpolar compound to the water, what will happen? It will create a certain disbalance in water among the water molecules, and water molecules will align in this mannered way, and it will cover the nonpolar molecules, and it form a cage-like structure around the nonpolar molecules. But this is energetically, it is not favorable. So what will happen because of these conditions? There will be disturbance in the water molecules. So now if we will add another molecule of nonpolar substance, what will happen? It will again bind with its the present nonpolar molecules, and it will clumped out. And anyone has given examination this time of CSIR net? Anyone? So there was a question also that if why we add glycerol with protein in a solution. So the answer is a similar, because some proteins are not non-polar in nature because of presence of their amino acids nature. So what will happen if protein molecule will be there, and we will add the another molecule, then it will aggregate and it will precipitate out. Okay, it will form a precipitate. It will not be remain in the dissolved form in the solution. So when we add glycerol to it, so we know that glycerol has OH ion, or hydroxyl group. So it will form a hydrogen ion, and it kept the protein molecules in the soluble form. What will happen? Glycerol will similarly align around the protein molecules, and it will create it will help to form the hydrogen bonding with the solution or the other glycerol molecules, and help to keep the protein in the soluble form. So such types of questions can be asked in the CSIR net. Okay, move to the next one. Yes, the interactions between the water molecule and the non-polar one is known as the hydrophobic effect. So these are the similar some properties of the water which you have to study to, because in the upcoming topics you will have to interact with such topics or such terminology. So I have discussed in very basics. So most similar questions which is asked in examination is about the pH. So pure water has a pH of 7. So what does it mean? So we express pH as negative logarithm of hydrogen ion or hydronium ion. Okay, so what does it mean? If we say that pH is 7, then what if we replace this equation of pH as 7, then what we will get? 7 is equals to minus logarithm of hydrogen ion. So when we'll take log this side, what we will get? Anti-log of 7. What will be the value of anti-log of 7? It will be 10 to the power minus 7, and it will give to the concentration of hydrogen ion. So if we have pH, then we can easily calculate the concentration of hydrogen ion, and if we have concentration of hydrogen ion, then we can calculate the pH. Okay. Uh, uh, who is here? Uh, it's Hello. Am I audible to everyone? Hello? Hello?
Yes, ma'am.
Yes,
Audible.
ma'am.
Okay. Okay. So who is it's Varsha, I think she is not connected. So leave it. Okay, so we can have either with the pH we can calculate the concentration, or with the concentration we can calculate the pH. So how we write the equations if we consider the water molecules? Water molecules, if you will consider it, then it will break into hydrogen ion and hydroxyl ion. But we know that hydrogen ion doesn't exist like this. It will combine with another H2O molecules, and it will give you hydronium ion. Okay, so but to express or to simplify the equations, I am leaving this. I am just expressing as a hydrogen ion and hydroxyl ion. So what will be the equilibrium constant? Equilibrium constant, we know that it is equals to the product by reactant. So here product is hydrogen ion and hydroxyl ion, and reactant is here water molecules. So what will happen at room temperature? We know that equilibrium constant is equals for water molecules. Equilibrium constant is equals to 1.8 into 10 to the power minus 16, and the concentration of water is 55.5. So now replace these values here. So what we will get? We will get here, when we multiply 1.8 into 10 to the power minus 16 with this water molecule concentration, which is 55.5, we will get 1 into 10 to the power minus 14. It is equals to product of the hydrogen ion and hydroxyl ion. Okay, so this equation we already know, but I have dealt with all this process because while solving the questions you have to this process can help you while solving questions, because I am going to give you some questions. I have some collection of questions which you can practice for your examinations. So we know that at pH 7, what we know that pH of 7, at pH 7 hydrogen ion concentration is 1 into 10 to the power minus 7. So how we will calculate the concentration of hydroxyl ion? It will go in below, and what we will get, hydroxyl ion as well as hydrogen ion at pH 7 is equals to the 1 into 10 to the power minus 7. So this will also help you while you will solve the problems related to pH. So I have here three questions related to pH. regarding how to calculate the pH, and such questions are also asked in CSIR examinations and also very common in GET and DBT examination. So how we calculate the pH, it's quite simple. If we consider the first case, HCl, it will break down into hydrogen ion and chlorine ion. So here concentration is given, which is 0.01 for the hydrogen ion. And and what will the pH will be simply the negative logarithm of hydrogen ion. So better I express 10 to the point zero 0.01 is as 10 to the power minus 2. So it will help in the calculations. So as here minus sign is there, to remove this, what we do, we take the inverse of the hydrogen ion concentration. Okay, so when we will calculate this, what we will get, log is equals to, when we will take the concentration as the 1 by 10 to the power minus 2, we can take it also as 10 to the power 2. Okay, so I'm directly putting the value as 10 to the power 2. So when we will take the logarithm of this, so what we will get, the pH as equals to 2. Similarly, here the question is about the NaOH. So here what we will have to do, here it was given the hydrogen ion was there, but now here NaOH is there. So first what we will do, we will calculate the concentration of hydrogen ion from hydroxyl ion. So how we do this? We will take NaOH as Na positive plus hydroxyl ion. So we have the concentration of hydroxyl ion. Better I express is in power as minus 3. So here we have 10 to the power minus 3. So we know that hydrogen ion into hydroxyl ion is equals to 1 into 10 to the power minus 14. So from here we can calculate the concentration of hydrogen ion, as when we will express the 10 to the power minus 3 here. So what we will get here, 1 into 10 to the power minus 14 by 1 into 10 to the power minus 3. So what we will get, it here 1 into 10 to the power minus, because it will go up and will become plus sign. So we will have here 10 to the power minus 11. So likewise, like I have solved here and got the pH 2, here what we will get the pH of this concentration, you will get the pH as 11. So likewise, this question will also be solved. I am leaving this question for you. But only difference is there was only one molecule of hydroxyl ion, so the concentration was 10 to the power minus 3. So now here the two molecule of hydroxyl ion is there. So what we will have to do, you have to multiply the concentrations with that of the two. What you will get, 10 to the power minus 4 will the concentration of hydroxyl ion, and from here you can calculate hydrogen ion concentrations and from their pH. So I am leaving this question for you. I have other questions also. I will mail you after this lecture. So
Excuse me, ma'am.
yes,
Yeah, can you take back to the previous slide?
which one?
The OHNO, this one, yeah,
Yeah,
calculation one.
calculation
Okay, you
high.
told that
Yes,
this is 10 to the power minus 3.
yes.
Okay,
Uh,
so is it like Na is 10 to the power minus 3 and OH is 10 to the power minus 3, or only the OH factor?
it's
Like
only
I did not get this. Why is this 10 to the power minus 3 and
okay.
why Na plus is not 10 to the power minus 3?
It will be also the, it is telling about the whole concentrations. It's Na plus
Huh, huh,
NaOH is giving the concentration of 10 to the power minus 3. Okay,
yes.
so there will be equal concentration of NaOH. Actually, there is another equations I am telling you, like Ha
Hmm,
is there. I have skipped this
hmm,
because you already have, I think I already all were knowing. If alpha quantity is there in the
hmm,
initial stage when there is no reaction is there, so after
hmm,
some time, after time t, suppose X concentration of Ha has been broken down into hydrogen and H and A. So what, how we will
hmm,
express is suppose x amount of Ha has involved and in the reactions, and it breaken down into
hmm.
H and A, then we will have x amount of A H and x amount of A. So this is why I have just expressed the for OH ion, because it was not included in the questions. Man, no need to
So
explain this.
it is
Yes.
Na minus 10 to the power minus 3 and OH is 10 to the power minus 3.
Yes, yes.
This
So
is when there is a complete dissociation.
yes, complete dissociation is there. May I proceed?
The compound is,
Okay, huh.
yeah,
Yes,
okay,
yes,
okay.
yes, yes. Any more question?
No, no, no.
Okay,
Okay, I'll ask later.
okay. So, we know that pH has a very significant role in our biological system. So, every enzyme, every protein has certain pH where it can function properly. So, and to maintain pH, there we use the buffering. Buffering means what we maintain the pH with the help of weak acid and its correspondence base. So, when there are certain properties about for the buffering capacity. First is that buffering capacity should directly be proportional to the concentration of buffer components. Buffer component is what here? Here it is weak acid and its correspondence base. So base will be the stronger one. So it is direct. If we are taking the more amount of weak acid, there will be more amount of base. So as there will be more amount of concentration of weak acid and base, there will be the more chances of buffering capacity will be more. Next statement is that buffer contains equal concentration of acid and its conjugate base. So I will explain this with equations. Let me read out another one. Another is that buffer is more efficient at or near the pK of the acid conjugate base pair. So what does it means? Buffer generally have the weak acid and its correspondence base. So we know that for the dissociation constant for acid we represent it as A, and when it is in equilibrium then we will have the reactant by product. So H minus H into A will be by HA. So what we will get here, we are generally focusing on the pH. So pH, how we express with the concentration of hydrogen ion. So let's express it in the term of hydrogen ion. So when we'll express in terms of hydrogen ion, and when we'll take the negative logarithm of hydrogen ion, so what will be it? It will give the pH. Sorry, it will be the pH. Okay, and it will be the pK value. So the one which have the compound or the solution which we are taking as a buffer, it should have the pK value almost equal to or around the pH value of the system which we want to keep in the equilibrium. First point was that is the buffer is more efficient at or near the pK of the acid conjugate base pair. Next point is that equal concentration of acid and its conjugate base. So when pKa value will be equals to the pH, when the concentration of the acid, weak acid and its conjugate base will be almost equal, then it only possible that pK of the buffer will be around the pH of the system. I am taking here the example of blood, buffering capacity in blood. We know that bicarbonate are the basic buffering agent in blood. And what is the pH of blood? Blood pH is 7.4. But here I have told that if bicarbonate, we are using bicarbonate as the buffering capacity for the blood, then its pK value should be near to 7.4. But it is not so. Actually, it is 6.37. Even then, we are using bicarbonate there. So why we use bicarbonate? Even then, its pK value is not equals to that of the blood. So the answer is that not only bicarbonate is only involved here. It's mean pK value equals to pH. Yes, it means pK value will be equal, almost equal to around the value of pH, because at that point it will able to maintain this pH, because if obviously if you are around the answer, then you can obviously answer that question in right manner, no? So pK value should be around the pH value, but even then, even bicarbonate don't have the pH value of around the 7.4. Even it is used as a good buffering agent in blood. This is because another two organ of our body is there. One is lung and kidney, which is involved in to maintain the pH of blood. And this question, please concentrate on this topic because many of times questions are asked from the buffering capacity, especially of that of the blood or blood. Okay, so what happened when acidosis take place? Acidosis means what? When the pH falls below the 7.4, basically 7.38. So what will happen? It means that hydrogen ion concentration is more there. On that time, what we will do, uh, or we can say that in our body we have the more carbon dioxide. So if more carbon dioxide will be there, then more hydrogen ion will be formed because we know that to maintain the equilibrium, it will shift toward this right side. So to maintain the hydrogen ion concentration, what will happen? Lungs will play its role and it will exhale out carbon dioxide outside. Okay, uh, sorry. So hydrogen ion concentration will be more because of the more carbon dioxide, and on the same time kidney will start liberating bicarbonate because we know that from nephrons it can absorb or it can release bicarbonate. Kidney can release or absorb bicarbonate. Okay, so what will happen to compensate this excess amount of hydrogen ion or the acidic condition? Our lungs will exhale out carbon dioxide from itself. So what will happen, as there will be less concentration of carbon dioxide, so now to maintain the equilibrium, this bicarbonate will combine with the hydrogen ion and it will shift the reaction toward the left side and acidosis conditions can be maintained. Another condition can be there when there will be alkaline conditions. It means that when the reaction is more toward the left side, on that time what will happen? What we will have to do, we will have to switch the reaction from left to the right. So if we will increase the concentration of carbon dioxide, then we can shift the reaction toward the right, or we can increase the concentration, or sorry, we can decrease the concentration of bicarbonate, then also it will shift toward the right side. So what will happen? Lungs will undergo hypoventilation. Hypoventilation is the conditions when lungs will start releasing more and more carbon dioxide toward the blood. So as soon as carbon dioxide concentration will increase, it will move the reaction toward the right side and it will pop up with the alkalosis or the acid basic condition of the blood by increasing the amount of hydrogen ion. And also kidney will also play a role there. It will then start absorbing bicarbonate, and because of this also the reaction will shift towards the right side and alkalosis conditions will be pop out. Okay, everyone understood this? Hello, everyone getting the points?
Yes, ma'am. Got
Okay,
it.
okay. So there are certain formulas in relation with the pH and the buffer solutions, and questions based on these formulas are also been asked. So I am just noted out here the formulas. You better keep these formulas in mind, and I will give you some questions based on this formula for the practice after this lecture. Okay. So these are the few formulas there. So, another point is that if questions can also be asked like this, let's suppose there are three compound is there, A, B, C compound is there, and pK value, Ka value of A, Ka value for B, and Ka value for C is given there. And such questions are generally asked in the part C questions. And if you once get the concept of this, you can easily solve these questions, and you can never miss these 4 marks from the part C. So the question is that, sorry, the concept is that the smaller the Ka value, stronger will be the acid. Okay, so it is asked the Ka value is increasing as like this, so what will be the which one will be the stronger acid? Can anyone answer which one will be the stronger acid? My point is here, more the Ka value or smaller the pK value, stronger is the acid. So anyone can answer which will be the strongest acid of A, B, and C? Yes.
Uh, the one with the lowest KAC.
Uh, yes. Yes. HKC, because it has having the smaller value of K. Okay. So okay, so these were all about the pH. Another thing which regulates our system is the heat. So this heat we study under the branch of thermodynamics. So basically we use two terms in thermodynamics. One is the system and another is the surroundings. So system is any body which is having a definite boundary and have a definite function there which can isolate it from the surrounding. So if we suppose that any system will have energy, suppose E1 is the internal energy of the system, and if we are giving some more energy, Q amount of energy on the system, and also doing some work on the system, on that case what will happen, internal energy will change. Suppose E2 is the internal energy which is changed after adding Q and W. So what will be the change in internal energy? Internal energy change will be E2 will become what? E1 plus Q plus W, and del E, which represent the change in the internal energy, is equals to the energy given by outside the from the surroundings, plus W is the work done. Okay, so this is the formula. Such questions can also be asked just based on this formula, and this will be so easy questions of the net. So there are certain points. So if system will absorb energy, then it will be positive. If system will release energy, it will be negative. If work done will be on the system, it will be positive, and it will, if work done by the system, then it will be negative. Okay, so you can simply by the language of the question we can simply change the sign of your Q and W. Okay. Next point is that we can also express E was the internal energy, and here H is the enthalpy. Enthalpy is what? Is the internal energy plus PB. What is the PB? There we have represented as the Q plus W. Okay, the internal energy here it's the Q plus W, and what is the W? We know that work done can also be equals to the pressure into volume. So what will happen? Suppose it's a pistol, and if we are applying a pressure P on the pistol, it will, and there is certain gas there, so its volume will decrease down. So there will be certain change in the volume. So with the change in volume, what will be the change in enthalpy? Enthalpy change will be, and because of change in volume, because work is done on the system, so some amount of internal energy will be also changed there. So change in enthalpy will equals to the change in internal energy plus pressure is having constant here, and only it is changing the volume. So it will be equals to the del E plus P del V. We know that PV is equals to and RT. So if there are certain equations, suppose here AB is there, and we are expressing it, suppose A amount of A we get and B amount of B we are having. So and here it's having power A, power C and power D. So what will be the change in the we say we call it as stoichiometry. So what will the change there? It will be A plus B minus C plus D. So this represents this del Ng. So what if we will replace the P del V value here, then what we will get? Change in entropy will equals to change in enthalpy. Change in enthalpy will equals to the change in I'm sorry, I myself confused. I'm very sorry. Change in enthalpy is equals to change in the internal energy plus change in Ng plus RT. RT is the gas constant and T is the temperature. I have notes for you where I have noted all the possible values of R with respect to the pressure and volume. Okay, I will give that to you. Next is that if we are talking about the enthalpy, so from where this enthalpy is coming? So when suppose we are breaking glucose into galactose, we are making breaking galactose into glucose, then there some bond will break here and some bond will form here. So the change in some amount of energy will be absorbed for the formation of bond, and some energy will be released in the breaking of bond. So what will happen, the change energy required to break the bond, break the bond of uh, to break the bond of galactose minus the energy required for the bond formation of the product, which is glucose, is the del H. Okay, so this is all about the first law of thermodynamics, which means energy cannot be changed, not be created, but it is changing from one form to another. If we move toward the second law of thermodynamics, it states that energy of the universe is conserved whereas its entropy increases in a naturally occurring or spontaneous process. It means that in system uh, energy will be energy will be conserved in the surrounding, energy will be conserved just to change from one form to another. So if we will take the whole amount of energy, then if the reaction is spontaneous, it means if the reaction is favorable, in that condition entropy will increase. So when entropy is increased, it will never go negative, so it will always be greater than 0. We also express del S as equal to or greater than del Q by T. It will function of the temperature. Okay. Now how we express the gas-free energy in terms for, hello? Any question? Hello? Okay. So if we express the Gibbs-free energy for the spontaneous reaction, so what will be it? Uh, it will be equals to, in the terms of entropy and enthalpy, Gibbs free energy is equals to enthalpy minus T into entropy. It is the temperature. So change in Gibbs free energy will be equals to del change in entropy minus change T into change in enthalpy. So these question based on these equations are also asked. Okay, another equations is that, another point is that if we have given certain equation only, and if we have to ask that if is the equation is spontaneous or not, so from simply from the del G value we can determine whether the reaction is feasible or not. If the value of del G is negative, then the reaction is feasible. Or if the del G is 0, then it will be in equilibrium, and if it will be positive, then it will be non-spontaneous or non-feasible. Now, uh, another equation is that del G is equals to standard Gibbs free energy plus RT log to the base EQ. And what is Q? We have expressed K as the equilibrium constant. Suppose there is a reaction of AB and it will break into A plus B. So just before attaining equilibrium, just before the equilibrium, suppose some X amount of, just before equilibrium, AB, X amount of X, AB has changed into A plus B. So on that case, we will not express K as the equilibrium constant, because we will express K when it will be in equilibrium point. So as this is not in the equilibrium point, we will express it as a Q, which is known as reaction coefficient, and it will be equals to, similar to that of K, it will be equals to A into B by AB. So condition can be there when equilibrium will be reached, then this Q will be equals to the K value. So at equilibrium, what will happen? Q will equals to K and del G equals to 0. Okay. So if we will replace the value of Q and del G here in the equation, then what we will get? We will, replacing the 0, we will get what? Del G is equals to minus 2.303. From where we are getting 2.303, we have change this log to the base e as the log to the base 10. Okay, so this 2.303 is coming by changing the log base value of the log. So very simple questions can be asked just based on this formula also. You have to remember this formula also. Another questions can be also based on the Faraday's constant or redox potential. As this time also there was called questions and very simple questions, and that was in part C. Simply the equation was there where you were given the redox potential and del G were also there, and from there we have to determine the feasibility of the reactions. So simply the concept was that, yes, anyone? Hello? Okay, so simply the concept was that if we are having the negative, more the negative del G value, more the feasible the reaction will be, and redox potential is what means it can accept or release the electrons. So the one which you will release the electrons, it will be in the lower energy. So electrons from the higher energy will be transferred to the lower energy. Okay, so the more the E naught will be, more the feasible reaction will be. So these were all about the basics concept about the biochemistry. I have dealt all this basic concept because if we are talking about the biochemistry, in the whole process there will be chemistry, and there will be each and every reaction will be controlled by this thermodynamics process and the pH value. So let's start. May I continue for the next topic? Everyone is okay? Not tired now? Hello? May I continue?
Yes, ma'am.
May I continue? Okay. So macromolecules of the living world. I have talked about the elements of the living world, and they will combine together with certain bondings to form the macromolecules of the living world. So basically, there are five types of macromolecules in the living world. These are the carbohydrates, lipids, proteins, nucleic acids, and vitamins. So I will deal one by one this whole. So let's start with the carbohydrates. Carbohydrates is basically we say as the hydrates of carbon. Why we say is hydrates of carbon? So if we will look the general formula, it's the carbon is there with the molecule of water. So another name of water is what? Hydrates. So we can say it as a hydrates of carbon. And how we express the carbohydrates monomers unit as CH2O whole to the power n. And if n will be equals to 3, it is the smallest molecule of uh, carbohydrates, which is glyceraldehyde. Okay, and there are three classes of carbohydrates. There monosaccharides, disaccharides, and oligosaccharides. If we are dealing about the carbohydrates, then there are certain property of the carbohydrates. One is the chirality of the carbon. If all the bondings group around the carbon will be different, then the carbon is known as chiral compound. Okay, so glyceraldehyde is the smallest molecules of carbohydrates, and we take it as a reference molecules because as first condition is that it's the smallest and it is easy to handle. So there are two categories. We design it as D and L. D and L here if we are representing as if hydroxyl ion will be on the right hand side, then we will consider it as D glyceraldehyde, and if it will be on the left hand side, then it is the L glyceraldehyde. And this, if you will see, these two are the mirror copy of each other, and such as enantiomers, stereoisomerism, having the mirror copy is known as enantiomers. Okay. Another term we write it as a small d and a small l. What is the difference between capital D and a small d? So, if we are taking a D-glyceraldehyde, because the hydroxide ion is on the right hand side, it is the D-glyceraldehyde. So, when we are taking a polarized light and we are facing toward our eyes is facing toward the polarized light or the path from where polarized light is coming, and when it will pass from the solution, I have taken here the one molecule of glyceraldehyde, but actually it's the solution of glyceraldehyde in a beaker. So suppose it's a beaker, and here we have the solution of glyceraldehyde. So when the polarized light will pass through the glyceraldehyde, it will rotate the polarized light to certain angle. So if our eyes looking toward the polarized light, and if it seems that light has twisted toward the right, then it is known as dextrorotatory, and we represent it as the D, small d, glyceraldehyde. And when it will be rotated toward the left side, on that time we will represent it as levorotatory or with a small l as a L-glyceraldehyde. So capital D or small d is the different thing. capital D, or the if hydroxyl ion is on the right side, it doesn't mean that it will always rotate the plane polarized light toward the right, or it will always or it is rotating it toward the left side. It doesn't matter whether it is in the right side or left side. It depends on the property of the glycerol, on the structure of the compounds. Okay. So racemic mixture is one which is having the equal amount of D and L form, or the dextrorotatory or the levorotatory. And that conditions, what will happen if we have three molecules of glyceraldehyde D and three molecules of levorotatory glyceraldehyde. Then what will happen? This dextrorotatory will rotate the polarized light toward the right side, and this will rotate the polarized light toward the left. So what will we have the resultant? We will have the resultant with the no polarizing activity. It will be non-polarizing activity. So such mixture having the equimolar concentration of dextrorotatory and levorotatory compounds will be known as racemic mixture. Epimers is what? If a compound differs in only single carbon atom, as it's a structure of D-glucose. If it is differing from the D-glucose in only one carbon, which is number 2, then it is the then we can say that mannose is the epimer of glucose, and likewise galactose, which differ from glucose from only one carbon, which is carbon number 4. We can say that glucose is the epimer of glucose. Sorry, galactose is epimer of glucose. Okay. So another term is the mutarotations. You might uh, in the cyclic form, we have represented the D and L form when it is in the linear form, but we represent basically as the alpha and beta form during the cyclic form. So what it is? So if we remember, then we have equation as alpha D glucose. Okay, it will be in equilibrium conditions. In the equilibrium condition it will be, and it will again change into beta form. Then why it is changing from alpha to beta, and what does it mutarotation means? It has changed into beta D glucose. Okay, so what is the mutarotation value is? I have told that light will rotate. The compound will rotate the light at certain amount. So what happened if it is in the alpha form? Then it will rotate the plane polarized light to a certain value, which is plus 112. Okay, wait a minute. Are you getting my points? So it will rotate the light toward the angle of 112 degree, and the beta D glucose will rotate it by the angle of plus 18 18.7 degree. But in equilibrium we have the rotations of 52.7 degree, plus 52.7 degree. So how did this comes? What happened? And how it changes from alpha to beta, and how we express the alpha if this is the glucose compound in the cyclic form. If hydroxyl ion will be toward the lower side and hydrogen ion will be on the top, then we can say that it is the alpha form of glucose. And if hydroxyl ion will be on the top side and hydrogen ion will be on the lower side, then it will be beta form. So you might have always confused that which how to remember that. You might have forgot this types of structures, that is this is beta form or alpha form. Then I am telling you a very simple way to mug up this. If this is the structure of, sorry, cyclic form of glucose, simply write beta. How we write beta here? Like this. So for in the beta form, hydroxyl ion will be on the top and hydrogen ion will be on the downside. So I hope you will never forget this structure. So now what will happen in a solution? If we have a solution of glucose and water molecule is there, so what will happen? Water has H plus OH. Okay, so what will happen? Lone pair of hydros of what? of water will first attract, sorry, glucose molecule also having the lone pair. So what will happen? First of all, this lone pair will attack on the hydrogen and OH bonding. So to compensate this, bond will be shifted, or it will be attracted toward the oxygen. So because of these conditions, to compensate this bonding will compensate for, sorry, this bonding will compensate for the loss of electrons from the oxygen. Because of this weakening of bonding, this bond will break out. So how it will form? It will change into the, yes, any questions, anyone? Hello, hello, once again. Yes, Oris, what you want to know? Please once again explain difference between capital D and small d. Okay, I'm repeating. Move to the next slide. Okay, so capital D, what was it? We have generally, yes, we generally take a reference of glyceraldehyde as a D. If the hydroxyl ion will be on the right hand side, then we term it as a D-glyceraldehyde, or if it will be on the left hand side, then we generally term as the L or the L-glyceraldehyde. So we'll take this glyceraldehyde as a reference. So if also we have the fifth carbon compound, in case it will be in the case of glucose, fifth carbon compound will be of in glucose. If it will have the hydroxyl ion on the left hand side, then it will be L glucose, and if it will be on the right hand side, then it will be the D glucose. And it doesn't mean that it will rotate. It is rotating the light, polarized light toward the right side, and this is rotating toward the left hand side. Polarization is different concept. So what will happen when we have the plane polarized light, and in a exposed to, if we will expose a solution of glyceraldehyde or D-glyceraldehyde, capital D-glyceraldehyde, with the plane polarized light, and we face toward the this beaker, then what we will see, if this light will be rotated toward the right hand side. Okay, it suppose if we are twisting anything in the clockwise direction, so what will happen? So if it will twist toward the right hand side, then we term it as the dextrorotatory or small d. Here we will represent it as a small d. Okay, and if we twist our hand toward the left hand side, or the light is twisted toward the left hand side, then it is known as levorotatory, and it is represented as L-glyceraldehyde. Okay, got it, Soris? Okay, moving towards the next slide. Oh, yes, mutarotation. So, because of this attraction of the electrons, there will be a weakening of bond between oxygen and hydrogen. This carbon and this oxygen. Because of this, this bond will break and it will change into the linear form. Okay. Now, what will happen? This has changed into linear form, but this carbon atom has get the positive charge, and here we have the hydroxyl ion this side, and also hydroxyl ion has also oxygen, which can have the lone pair of electron, and the hydrogen ion toward the upside in the case of alpha D glucose. So what will happen? To compensate this positive charge, this lone pair of electron will be donated to this bond. Because of this, it will get the partial positive charge, sorry, double bonding. But before getting the partial double bond charge, there, because what happened when you will cut any twisted chain or twisted rope, what will happen? It will start getting its comfortable positions. So as soon as this bond will be cut down, or suppose this is a rope there, रस्सी जिसे बोलते हैं, rope there, and if we will cut with the scissor, then what will happen? It will start twisting. Okay, so because of this twisting, this hydroxyl ion will be switched toward the upside, and this hydrogen ion will be switched toward the lower side, and now this has changed into the beta conformation. This is how mutarotation take place from alpha to beta form. Now hydroxyl ion, having the partial character of the double bond, has twisted toward the twisted and formed from the alpha, it get converted into the beta form. And now the reaction will be in inverse direction, as it was attracted toward the electron was donated to the hydrogen ion in case of to the in the solution of water. This time hydrogen ion will again back the electron which it has gained from the oxygen, and again the bond will form, and now alpha has changed into the beta form. Now my question is that which form is more stable? From this equation, can anyone tell that which form is more stable? Yes, anyone can. Just try to answer so that I can understand that you are aware in the class, not sleeping. Yes, anyone can answer which one should be alpha or beta, which one should be more stable. I will tell reason behind that, why the certain uh, process is taking place. Yes, anyone? Are you listening me or not? Alpha form. Alpha form because it is rotating more light. No, actually, rotation is different thing and stability is different thing. So, cyclic form, we know that yes, beta. Obviously, if it is not alpha form, then it will be the beta form. Okay, so we express the cyclic form in two way. One is the boat conformation, and another is the chair conformation. Okay, so chair conformation is more stable than the boat conformation. Okay, so what? Yes, any question, anyone? Okay, no questions. So chair form is more stable. I am not able to draw it correct very nicely. So understand this. This is the chair form, and this is the boat form of the hexagonal glucose. So what happened in the boat form? The arrangement of hydroxyl ion will be almost parallel to that of the oxygen. Okay, so because of this, there will be less steric hindrance. But in the case of alpha, the hydroxyl ion in the beta form, alpha form, in the beta form, it is parallel to that of the oxygen. Because of this, there will be the less steric hindrance and it will be more stable. But in the case of alpha form, it will be perpendicular to that of the oxygen, and the steric hindrance will be more there. Because of this reason, beta form is more stable as compared to the alpha form. Okay. Next is, there are certain chemical properties are there, and questions based on the chemical properties are generally asked. Certain questions can be twisted in twisted form. Basically, there will be in part C. So first is the taumerization or enolization. This is the basic conformation. So what happened? The first two carbon of D glucose undergo under alkaline conditions undergo when we will add the alkaline solution to the glucose for after several hours, it will change into enediol. After that, enediol is very flexible and it can convert into d-fructose and d-mannose. So all this process take place under the alkaline conditions, and it takes so much of the time. So this process is known as tautomerization or enolization. It's also known as Labriti, Bruin, Vaughan, extent transformation also. Okay. So next property is the reducing properties. This is generally due to the presence of free aldehyde and keto groups. If there will be free aldehyde and keto groups will be there, then then that sugar will be the reducing property. Okay. So this property we use to test for the Bandic test, Fowling test, sorry, this is test, it is test, etc. How this happens? What happened? First of all, sugar will be changed into in a diol form, as I have discussed earlier in the tautomerization, that it will first change into in a diol, and then what will happen? Copper sulfate. What we add in Bandic solution, we add copper sulfate. So from the copper sulfate, this cupric form of copper will be extracted out, and this enodiol will then reduce this cupric form of iron into cuprous form. Cuprous form is actually and this enediol will be converted into the sugar acid. So what we do when we in the Bandix test, what we do, we take a solution of the sugar here, then we add copper sulfate in this, and then we apply heat to the solution. Then either we will get the yellow colored compound or we get the red colored compound. So yellow compound is that of the copper hydroxide and the red color is that of the Cu2O. Okay. Next property is oxidation. Oxidation is due to the presence of aldehyde group, or it can also be due to the alcoholic group. Next property is reduction. Reduction is that we know in you have also heard in different compounds, I'll say that we are reducing it to the double bond to single bond. So when this double bond is hydrolyzed with the hydrogen, this bonding will break down and it will convert it into alcoholic form, or the aldehyde form will change into the alcoholic form. This is known as reduction. So after reduction, what we'll get, if we will using glucose, then it will reduce to D-sorbitol, galactose reduces to D-dulcitol, mannose into D-mannitol likewise. I will give you this slide also after this lecture, don't worry. This sorbitol and dulcitol has a very significant role in the cell. It actually affects the osmotic pressure inside the cell. Next chemical property is dehydrations. So when we use concentrated sulfuric acid, monosaccharides undergo dehydration and it will eliminate 3 molecules of water. Likewise, polysaccharides or oligosaccharides, as it can not reduce 3 molecules of water, it can be dehydrated in the polysaccharide or oligosaccharide form. So what will happen? It will first hydrolyzed into monosaccharides by acid and it will followed by dehydration. So here, if we are using the monosaccharides, then it will release the 3 molecule of water from the glucose molecule and it will form the hydroxymethyl furfural. So this is the compound which we get the furfural, we known as furfural compound. But if there will be pentose sugar, if this is the hexose sugar, we are getting hydroxymethyl furfural. But if we will have the pentose sugar, then we will have only furfural. Okay, and this is known as sorry. Uh, if we will using the pentose sugar, then it will give furfural compound. And dehydration is the basic mechanism for the Mollis test, for the Biles test, and for the Mucic acid test. Another property is the oxygen formation. So what happened? Only first 2 carbon of any sugar will involve in the oxygen formation. So first, how it attack the how the what we do, we add the phenyl hydrazine there. So it will attack step by step in the carbon 1 and carbon 2. First of all, phenyl hydrazine will attack the aldehyde group, and then it will attack on the hydroxyl group and will form the glucose. Okay. Now, all these were about the monosaccharides, and what about the disaccharides? So, questions simples from the disaccharides. It can there you can also be asked like the monomers units of maltose, monomers units of lactose, whether this disaccharide is reducing or non-reducing. So, how we can distinguish the disaccharide as a reducing or non-reducing? I already have told that free aldehyde and ketone group will be there, which will involve in the in the as a reducing agent. Okay, so maltose is formed, any disaccharide is formed by a reaction with one hydroxyl group and one hydrogen of the two compound or the two sugar molecules, as here maltose having a monomer unit of D glucose and alpha glucose and beta glucose. Okay, so there will be the formation of alpha linkage by liberating one molecule of water and it will form the alpha 1,4 glycosidic linkage. So you also have to remember the types of bonding and what are the monomers compound. Okay, so yes, the next point is there. The thing is that to act as a reducing agent, uh, free aldehyde group should be there. So I have discussed how how this cyclic form will be converted into linear form, while I have discussed about the mutarotation. So as if you will see there in the maltose, we have here the bonding which can break and it can convert into the linear form. But here if you will look the alpha glucose form, this bonding has involved in the alpha 1,4 glycosidic linkage, so it will not break down. But here one aldehydic group is there which can involve in the reduction. So it's maltose is the reducing sugar. There are other sugars also. I have given this picture from the lineager. You can simply remember the monomer unit of the different disaccharides and the what types of bonding is there. You have to remember this. Such questions can be asked from this also. Okay. So if lactose is there, now suppose in lactose also here aldehydic group is there, and where bond can be break and it can involve in the as a reducing agent. We can also say that lactose is also a reducing sugar. But in case of sucrose, if you will see here, this aldehydic or the hexose sugar, glucose is involved in the bonding, and also this pentose sugar, which is fructose, has also involved in the bonding. So there is no free aldehydic group there to participate in the reduction reaction. So it is sucrose is non-reducing. Likewise, trehalose is also a non-reducing sugar, because here free aldehydic group has involved in the bonding. So all these were the disaccharides, polysaccharides. Yes, any questions, anyone? Any question? Hello? Hello? Any question? I think someone is having the slow network. Okay, I am proceeding. Any question, anyone?
Actually,
Yes.
we were not able to hear the previous slide.
Which one? Disaccharides.
The previous, yeah,
Yes.
disaccharide.
Okay. Disaccharides. Uh, so what happened for the from the beginning? Now I should start from beginning. So all these were about the no आप जिन्हें वॉइस नहीं आएगा या जिन जो डिस्कनेक्ट हो जाएंगे, जो लिंक मैंने सेंड किया है, यू प्लीज क्लिक ऑन द लिंक अगेन, यू विल डायरेक्टली कम टू द क्लास. ओके. So what will happen if we have the monomer unit of glucose, yeah, alpha glucose and beta glucose is there. So with the this hydroxyl group will involve in the bonding or in the reactions during the formation of disaccharide, and it will release the water molecule there and form a certain linkage. So as example, I have taken here of the maltose. This hydroxyl ion of alpha glucose and hydrogen ion of the beta glucose will react with each other and release the water molecule, and it will give the alpha 1,4 glycosidic linkage. So I have discussed about the reducing sugar. So for having a reducing sugar, what should be there? It should have the free aldehyde group. So if we will look to the structure, and how if we will say that this bonding has involved, then how we can say that this aldehyde group will involve in the as a reducing sugar. So because I have discussed in mutarotation that while having it is switching from alpha to beta form, what happened, this bond get breakdown and it will change into linear form. But here in alpha glucose form, this bonding has involved in the 1,4 glycosidic bond, so there is no chance of breaking of this bonding between the carbon and oxygen. But if we'll move toward the beta glucose, then there can be chances that as these bonds are free, this carbon and oxygen bond is free, so this can break down and it can change into linear form and it can participate in the reduction reaction. So maltose sugar is the reducing sugar. Likewise, in lactose sugar also we have free aldehyde group, and so it can be a reducing sugar. But in case of sucrose, if you will see the glucose molecules as well as the subunit of fructose, both have this carbon has involved in the bonding. So it will not able to form any it will not able to involve in the reduction reactions. So sucrose is non-reducing sugar. Likewise, trehalose also having this glucose molecules carbon is involved in the bonding, so this will be also non-reducing sugar. Now clear this time? Hello, clear? You can directly message yes if it is clear. Clear to everyone? Hello, yes, okay. Okay. So now move to polysaccharide. Polysaccharides can be homopolysaccharide. Polysaccharide means number of monomers unit will be more than 3. So it can be homopolysaccharide and it can be heteropolysaccharide. So if it will be homopolysaccharide, it will have the similar same monomer units will repeat. But if it will be heteropolysaccharide, monomer unit will be different. For example, in case of starch, we have the amylose, have a unit of amylose and amylopectin. What is the difference between amylose and amylopectin? Amylose is also the having the monomer unit of glucose, but the linkage is here 1,4. But in amylopectin, there will be 1,4, 1,6, 6 linkage, and another will be 1,4 linkage. Likewise, this if these are the sugar molecules and 1,4 linkage is there, then it is amylose. And uh, please switch off your speaker because my sound is echoing to myself. So and amylopectin will be what one, there will be 1,1,6 bonding, and then another will be again 1,4 bonding. Okay, so such branching will be what after every 24 or 30 residues, one bonding will be 1,6 bonding and other will be the 1,4 bonding. Likewise, glycogen also has similar types of structure. The only difference between starch and glycogen is what? The branching was repeating with the 24 and 30 residues, but now branch will be there after 8 and 12 residues. Okay. Cellulose is also example of homo polysaccharides. Chitin is also homopolysaccharides, and here roles I have noted out here. You have to just go through it. I'm not going to tell one by one everything. I will give you this slide. Next is the peptidoglycan. Peptidoglycan is what the, please switch off your speaker. Okay, peptidoglycan is what? It is the heteropolysaccharide. So one unit will be the NAC and one unit will be the NAM. So these are having the different monomer units. So it is categorized into as a heteropolysaccharide. Another examples are hyaluronic acid, chondroitin 6 sulfate, dermatan 4 sulfate, and keratin 4 sulfates. And what are these? These are having the repeating unit what? Galactose and glucose, and having the bonding as 1 beta 1 3 along with the alternate bonding of 1 3 and 1 4. Okay, so all these were about the polysaccharide, about the glucose or carbohydrate. In the next class I will deal about the lipids. Okay, I have uh, some another thing also. This was a syllabus, and this is the some points I have noted out here. So I will share this in the group. R value is there, certain qualitative properties. I have noted some of the points, and here are some questions based on the pH and thermodynamics. You go through these